New lesson, something really useful and really interesting. We are going to get some data from a game object in Unity and then apply that to a sound effect. Basically, take some parameter that's present in our game world, assign a numeric value to it or draw a numeric value from it based on what Unity gives us, and then use that value to determine how a sound effect is going to play back and how it's going to sound when it's cued in FMOD. This is a really, really useful technique so that as different events unfold in your game, how a collision happens or how fast something is moving or any other variable like that will have a say in what happens with the sound effect that's meant to accompany that event. In order to get this going, I need to get a few things set up in code first, just because it'll be easier to see all of this stuff. I've got my player controller script right here, and that is open in Visual Studio. First things first, just clean this up a little bit. We're not going to use this start function at all, so I am going to get rid of that altogether. We've got variables from the tutorial that we've been working on as part of this lesson. And if for some reason you're checking out this lesson and you aren't aware of the ones that came before it, you'll want to take a look at the playlist that this belongs to and loop back to the beginning, because this is building on some previous lessons with a basic Unity tutorial. Not difficult to get caught up, but something that you definitely need to do in order to be able to fully grasp everything that's here. Now that I've got my code started, and I'm just copying and pasting because I don't trust myself to type this out in real time in a way that's going to be all that useful in this format as a lesson. So I'm going to paste this code in, and I'm pasting it from another document with the comments. But the comments, well, useful. It's going to help explain exactly what we're going on. So this first line right here, I create a new vector 3 called where it was. And as you can see in the comment, the purpose of that is to just simply have some sort of variable that allows us to know where the vehicle is at any point in time. That will be useful in a velocity calculation. Then, since we are going to be calculating velocity, we actually need to have a variable for that. This needs to be shared amongst several different things within Unity and FMOD, so it's important that is a public variable. It's going to be a float. So public float, we call it vehicle velocity, and can just start with the value of 0.0 f so that the data type is correct, and we have our float variable in there. Now that we've got those variables in place, we can actually do the velocity calculation. And why velocity? Well, because this game is all about driving the car around, and you drive and you knock into stuff. So tracking the velocity of the car basically is going to allow us to determine how hard it hits any of the objects in the world, and then we can use that value to shape the sound effect. Calculating the velocity is this chunk that I just pasted in right here. In my code, it's lines 25 and 27, and then there's comments before it. The velocity calculation is right here. We're going to take transform.position, current location of the vehicle, and subtract that variable that we created earlier, where it was. So we want to know where it is now based on where it used to be. We'll get the magnitude, the difference between those two positions, and then divide that by time.delta time. And that is a really quick and easy way to calculate a velocity. How fast is this thing going right now? And then after we've done that, we want to make sure that we update our where it was value, because in the fractions of a second that it's taken for this to calculate, we want to make sure that we get a new value for where it was. So we're going to calculate that on every iteration of this update function. So once you have those lines, and feel free to pause the video if you want to look at this more carefully and get that code down exactly. But once you have it in place, make sure you save it, and then we can switch back to Unity, which is taking a while on this computer for some reason. There we go. And here we are. And then if you go over here to the hierarchy and highlight our vehicle, vehicle velocity shows up here in the inspector now. And this is really helpful to note because when we're working with this in FMOD, we need to know what the range of possible velocity values are. If we're going to take this value and assign it to a sound effect, we need to get a sense of what the full range is so that we're doing something that really connects with the state that will be true for the car and its velocity as it's playing in this game. So now as I drive the car down the road, take a look over here at vehicle velocity and watch that value. You'll see that it oscillates between 0 and 10. It's weird, sometimes it flashes and it looks like you get a bigger number there, but primarily it's just 0 and 10. Now, depending upon how you set your game up, you may find that that looks a little different. Velocity is always going to be a function of the maximum speed that you set there. So my speed happens to be 10. If your speed is higher or lower in your version of the tutorial, you're probably going to see a slightly different value there. If you want to be consistent with this lesson so that what I say agrees with what you have in front of you, go ahead and change your speed variable to 10 right now. You can always go back and adjust that and shift things around both in Unity and FMOD after the fact. But if you want to be consistent for right now, that may make things easier for you. But whatever the case, we can see that we've got vehicle velocity attached to our vehicle. We are getting values between 0 and 10. And what that means is that I can now go into FMOD and edit the events that we were working with before in order to reflect the possibilities of how that velocity value will change and have the sound effects respond in kind. So we're back in FMOD, and I am going to make this velocity value direct some changes here with the crate impact sound effect. Sound effect is like this. We've got this hollow wood thud, and then there's this more metallic rattle. And I think what I'd like to do is just have the velocity control what happens with just the metal. I kind of want that thud to be there no matter what, but I don't always want this to be audible, or I'd like it to be soft if the crate isn't hit very hard. Then if the crate is impacted more substantially, let's have a louder sound for a harder hit, basically. So in order to make this work, we need to create what's called a parameter in FMOD. And the easiest way to do this is to go to this empty tab and choose Add a Parameter Sheet. And a parameter sheet is just basically a way that you can edit a sound effect based on the values that come from a parameter. Well, we don't have any parameters in this project right now, so there's no sheet that we can assign, but we can do that right now. I'm going to call this parameter impact, and given that the velocity range that I saw in Unity was 0 to 10, I'm going to use that same range here in FMOD and set an overall possible value of 0 to 10 for this impact parameter. And once I've done that, we get a sheet that allows us to map out how this parameter may vary over time and what that might mean for the various audio tracks that are playing. This is one thing where FMOD can be a little bit confusing when you're looking at it for the first time, as we see this timeline, but it's no longer marking bars or beats. This timeline is actually marking parameter values, so 0 to 10. And in fact, if I grab this little slider right here and drag it up, you can see how this is now no longer a timeline in the way that you typically think of it as marking out actual time left to right, but it's showing us parameter values left to right. And what that means is here, track audio 1, and calling it audio 1 is a little abstract, so let's rename this, and I'm going to call this the crate hit. I'm going to call this the wood thud, or maybe not crate hit, it's really more of a metallic hit. Naming those tracks is helpful because then when I'm over here editing this parameter sheet, I can see exactly which one I'm going to control. And I said earlier that I want to do this in a way where softer impacts don't have the metallic sound or might make it less present. More substantial, strong impacts will hear all of it. And the way you do this is really pretty simple. Volume is the easiest way to control that. And so I will right-click on the volume knob for this track and choose Add Automation. And now that I have that, I can decide exactly where I want it to be. So I'll just click on this little envelope, drag that down, drag this back. I'm kind of making a mess of this. There's an easier way to do this, especially since we know we want it to be full volume when we have a hard impact. So I'm going to say, 5 is kind of the halfway point. So I'm going to set this to be 6. So if the impact is greater than 6, it'll be a full volume. But if it's less than that, we'll bring the volume down. And I think a little curve like that could make sense. So let's listen to this. Soft impact, we just get the thud. We bring up this value. Here's an impact of 4.8. So we get a little bit of metal. Here's an impact that's greater than 6. And we get the whole thing. And depending upon your sounds and how you want this to respond, you may want to set your values differently. You may not want to use the full volume there. There's a lot of room for adjustment. But this is the basic idea. And it means that depending upon how hard the crate is hit, we're going to get some volume variations of the metallic component of the sound effect, and that will give it a lot more variety as the vehicle smashes into the crates in our game world. So let's do this again, but I want to do it here with the barrier. And again, the idea with the barrier is we run into that object, it's made of metal, it's made of wood, so we get both metallic and wooden components in this impact. In the last lesson, we did some variation with the multi-instrument, we did some variation with the start offset, and we can continue to do more of that using the same impact parameter and approaching it similarly to the way that we did with the crate. First step, of course, is to add a parameter sheet. And this time, because we already have the impact parameter, we don't need to worry about creating it. We can just say we want to use that same parameter. Again, I'm looking at this generic audio 1, audio 2, so let's give this more useful names. That's my metal hit, and this is my wooden debris. So now we know what's what there, which is very helpful. And this time, I'm going to vary the volume. Let's vary the volume of the whole thing here. So I will use master in this case, and we can make sure we're doing this on our parameter sheet. Right click, add automation. Looks like I need to make that a little bit bigger. There we go, or just slide it down and we can see that. And what do I want? Well, I'm going to let this range be a little bit bigger, so we're only going to get full volume if we hit it really hard. But I don't want it to ever be completely silent, so let's just go ahead and back it down. And I'll start there at -20. What would that sound like? Okay, so we hear it, but it's softer. like that, for sure. I could adjust that as needed if I want to make that a little more gradual, maybe make it a little louder on the soft end. It was better when it was down there before. And of course, adjusting this now, we're kind of shooting in the dark. It's best to do this with live update after the fact and hear how it sounds in the game. But this gives us a good volume adjustment. Now, one of the other things that we did to vary this sound in the last lesson was here with this multi-instrument, we had a start offset. And that just determined, at what point are we going to start playback of this? And my idea was, well, there's more debris happening at the beginning of the sound file. There's less happening at the end. So if it's not going to hit it as hard, let's have it start closer to the end of the sound file. If we're going to have a more serious impact, let's let it play the whole thing. So we can right-click here where it says Start Offset. And I'm going to start actually by, let's just remove all the modulation. So everything that's in there, let's get rid of what was there from the last lesson, because I don't want to create any conflicts between that and what we're about to do. Then we can add automation. And when we do that, you can see that we've got automation down here. It's asking for an automation curve. We can add a curve, and here we can choose impact. And so this is giving us the same parameter that we edited earlier. If we switch over here, you can see in the impact parameter sheet, we've got start offset over here. We have the same thing listed over there. And so you can choose to edit in this part of the window or in this part of the window, whatever makes more sense to you. But what I know, again, is when we have a harder impact, I want it to play the entire sound file. So I'm going to set that value here at about 8.5. And so there will be 0% start offset. I don't want it to offset at all if it's going to be an impact that's greater than 8.5. But for softer impacts down here, let's say we're going to start about 2/3 of the way through. So I've got 65%, 66%. I can get that quite, yeah. And adjust the curve as needed. I think linear curve is probably as good a place as any to start here. And now we can test this. And I think it'll be easiest to see it if I switch back here, because we'll actually be able to look at this instrument and see where the start offset begins. So if I leave my impact at 0, and I didn't get anything. And there was a tiny bit of debris. You can't really see it here, but you can hear it. Let's bring the impact up a little higher. And there you could really hear it. Let's highlight that instrument. I'm not getting to see that the way that I hoped we would. It is highlighting it, but it's not showing us that little playback needle, which is helpful. I'm not sure why, but bring it down again. Oops, and make sure double click on the stop button to start from the beginning. Well, it definitely sounds right to me. I just don't see it updating the way that I would expect it to. But this is good. I think 66% might be a little too late overall. So let me open up modulation here for wooden debris. Let's bring this down. Let's see, how about 56%? Soft impact, a little bit of wood. Yeah, maybe a little higher. Okay, let's just go with 60 even and stop fussing over it. I think that should work, and again, we've got to test this in the game with live update to really know where we're at. So this gives us a couple different ways, and you should be able to take this idea and extrapolate it to so many different things. lots of different effects that could be controlled or modulated based on the way that we've done this. So if you wanted to, come back to this sound, and we're already doing some pitch modulation here. Well, if you wanted to let that impact parameter control the pitch, so for the barrier hit, we had lower pitch if it was a slow impact and getting closer to the original pitch for louder impacts. We could absolutely do that. You can follow this exact same process with just simply right-clicking, saying that you want to add some automation. You see it opens up an automation curve for that, and then here on the parameter sheet, we can adjust this and say, well, I want it to be at the original pitch. Whoops, I think it was at the original pitch. Yeah, 0 for higher impacts. Let's go to 7.5, but then I want it to drop down. Let's go to like -6 or so for slower impacts. So we're soft impact, and that's probably a little bit too low, all things considered. And then we have a higher impact and the hardest impact. And that works really well. And again, tweaking these parameters is a wormhole. You can do it forever and ever and ever. So don't let yourself get sucked in. Remember to iterate through, hear it in the game first, and then loop back. So that's a good place to leave it for right now. You've seen a bunch of different ways to automate these parameters and tie it to something that's going to be available to us from the game and help direct how these things actually play back. As always, before you move back to Unity, make sure that you save and build. And then once that's done, switch back to Unity, and we can take the final steps to implement this. Back in Unity, we can take our updated sound effect events using that impact parameter that we created and make sure that that is controlled by data that's coming directly from our game. In order to get a sense of how that might work, if you switch over to the FMOD events tab that's in your project, you can select any of the sound effects that we were just working with. In my case, I'm going to use barrier hit. And you'll notice that there's now an impact parameter that's tied to it here. And you can see that slider allows us to modulate between values of 0 and 10, and we've got floating point number. And this means, well, we can imagine, well, okay, if it was a softish impact, 2.17, that's what that sounds like. We get a slightly lower pitch, we get less wooden debris, we go with something that's closer to 10, and we get a sound that's a little louder, more forceful. It's doing exactly what we want it to do. This is a helpful way to test and just to make sure that after you saved and built your project in FMOD, when Unity updates those new assets, everything is translating correctly and performing in the way that you need it to. Now, to get this to work, we actually have to do a little bit of coding. And so I am going to go, let's see. We have our create sound effect with different values of metallic rattle. Let's go ahead and start there. There's something simple about that sound effect, and it's one of the first things that we can hit. So I'm going to select that first crate here in the hierarchy, and then down here where it says add component, I'm going to choose new script. This is an important step in order to make sure that we're all on the same page. Give your script this exact name, which is obstacle, capital O, obstacle, capital C collision, capital G get, capital V velocity. Obstacle collision get velocity. That's the name of our new script. Click create and add. And we now have a new C# script. And let me switch over, here we go, to Visual Studio. Fantastic. There it is. We can see that it's kind of sitting outside of the scripts folder right now. In the interest of neatness, I can just drag that down and put it inside the scripts folder, so everything is in that place, which is helpful for needing to find things later. You can see that reflected here in our here in Visual Studio. Double click to open this, and we have exactly what we need. All right, now that we have that, we are going to start to build this script line by line. So the first thing I'm going to do is create a new variable. And this is our variable for velocity. See, yeah, this is why I didn't type those out earlier. I'm terrible typing in front of an audience. We've got that, and then once we've defined a variable that we can use to keep our velocity, we also need to make sure that we can actually get that velocity value. Well, if you remember, that velocity value is in our player controller script, this script right here. We're calculating that based on the movement of that vehicle. And so we actually need to be able to access that vehicle from this script. So we create another variable, we call it vehicle, and then we set that equal to a game object that we will find in our game. We're looking for the name vehicle specifically, and I can search for that because here in my hierarchy, vehicle is what that's named. If you want your script to work correctly, make sure that this is named vehicle. Or if you name it something else, make sure that that's what you use right here in the script. If you want to be consistent with this lesson, renaming things in Unity may be an easier way to do this, just so you're not trying to remember which ones you swapped and which ones you kept the same. And now that we can find our game object, we will do a bunch of things in order to get that value from the vehicle and then apply it to our sound effect. We're not going to do that in Update, however. We're going to use a different event handler here. So I'm just going to get rid of the word update and replace that with capital O on, capital T trigger, capital E enter. On trigger enter is the event handler that we want to use right here, because that's what fires when a collision takes place, and the trigger that we've identified in Unity notifies us that that collision has happened. Now I'm copying and pasting from another document. I'm going to drop a bunch of code in there, and then I'll go through and comment this out line by line. You can copy it into your script and understand what's going on. We are just simply getting access to our player controller script, which we need because that script is where the velocity values are calculated. Now that we have access to that script by retrieving it as a component from our vehicle, we take that value of vehicle velocity that's inside of that script, and we assign it to hit velocity, the float that we are using in this script. So I'll say apply vehicle velocity to hit velocity for FMOD modulation. Technically FMOD parameter modulation. All right. And then I also put this line in here, and that will display the value in the console. So that way, when the impact happens, I get a printout in Unity, and I can see exactly what those values are. And that can make it easier for iterating through, tweaking those parameters in FMOD and making sure that different hits are going to sound different, and we're using the full range that's available to us. Now that we've been able to retrieve that data, we take the next step, which is simply to apply that value to our FMOD Studio event emitter. And if you've forgotten what that is, because it's not been part of this lesson, FMOD Studio event emitter is what's here in Unity. That's the element of code that's accessing the create sound effect and playing it on trigger enter. We need to let Unity know that that's where we want to use this value, and so that's what happens right here. We access the FMOD event emitter, that plays the sound effect. I think that's the best way to delineate that. As you type this line of code, look at the characters carefully. You've got some angle brackets, some parentheses, semicolon at the end. Important to get that exactly right in order for your script to behave correctly. And then, once we have access to that, we just simply apply our velocity value to the impact parameter and send to FMOD event. So that's basically saying, figure out what the velocity is when the vehicle hits this object, use that calculation from the other script, apply it or save it in our local variable hit velocity, and then use that value to assign an impact parameter value in FMOD and let that modulate the playback in the way that we set it up to work earlier. That should work. So I'm going to save my script. Make sure you save your script. If that's not been done, it is definitely not going to work when you switch back to Unity. Switch back to Unity. I've got some errors. Oh, yes, that's what I did. I forgot to tell the script what kind of data type this is. My bad. It is a game object. Yes, okay, it'll be happier now. Needs to know what vehicle actually is. Vehicle is a game object. All right, save that, move back to Unity, and good. Always happy to see no red down here. Absolutely. All right, so let's double check. Obstacle is here. The script is there. We don't need to do anything with FMOD because that event emitter is already attached, so I can play this back. Okay, collision. A little harder. Let me do a soft collision. Yeah, and we just get the thud. Excellent. Kind of medium. Yeah, great. It's doing exactly what I want it to. And once you have that one in place, you can go through and you can just simply grab that script that we wrote and drag it and drop it on your remaining obstacles. And this is one of the things about this process that's so fantastic is we have the same event and event emitter attached to all of these. The collision is happening between those objects and the vehicle, so nothing has changed there. So it's really just a matter of making sure that that script is present. And we get different sound. Oh, and remember when we wrote that print line in our code? Let's do a soft collision here and watch and see what happens in the console. Yeah, so there we had a collision that was 6.5. We try to do a really soft one. Yeah, 2.4. And then let's just go full speed ahead at this one. Okay, I guess I hit it a couple times there. Yeah, and there we got a collision that was, yeah, harder, closer to 7. And Unity looks like it's reporting some stray values too, but it's behaving mostly the way that we want it to. And now that we've done that, we can also just follow the same workflow and apply that code to our prop barrier as well. So I can take that same script, drag it and drop it here on the inspector of the prop barrier. And again, because we're working with the same basic ingredients and the parameter impact is the same across all of these, and we hit this at different velocity values, and we get different variations. You see that reported here in Unity's console, and we can hear it in our sound effects as well. So this is an incredibly useful technique that you can apply broadly in the way that I've demonstrated here in this lesson, and work with extensively in FMOD to eke out every little last bit of nuance and subtlety from the sound effects that you've designed in the middleware in order to get a greater variety of playback here in the game engine.